Have you ever felt the need to express situations where values are not just equal but vary in a certain direction? Hello, math learners. Hassan here. Today, we'll dive into the art of writing inequalities, where we'll be expanding our mathematical vocabulary beyond equals. Okay, so let's start writing inequalities. An inequality is a mathematical sentence that compares expressions. Usually, an inequality contains the symbol less than, greater than, less than or equal to, or greater than or equal to. So with these four symbols, we can understand that certain expressions are representing inequality expressions. So here we are basically replacing the equal sign with these inequality symbols. And that's how we differentiate between equation and inequality. Now, in terms of verbal expression, we use some key phrases to refer to these inequality symbols. The phrase that we use for less than is less than or is fewer than. So whenever these phrases are coming into the word problems, we typically use this less than symbol. The next is greater than. For key phrases, we use is greater than or is more than. For less than or equal to, we use is less than or equal to, is at most, is no more than. So whenever one of these three phrases are coming into the verbal expression, we use this less than or equal to symbol. And the last one is greater than or equal to. So if the key phrases are is greater than or equal to, is at least, or is no less than, then we use this inequality symbol. So that's pretty much of all we have for key phrases for each one of these inequality symbols. The more you can get familiar with these synonymous expressions, the better it would be when it comes to word problems. So here are three practice examples to convert the verbal expression into algebraic inequality expression. So the very first one, we have a number w minus 3.5 is less than or equal to negative 2. So over here, we can see that the number w minus 3.5 can be translated as w minus 3.5 is less than or equal to can be translated as this symbol over here, and then we have negative 2. So our inequality expression is w minus 3.5 is less than or equal to negative 2. This is how we convert the verbal expression into the inequality expression. The second one we have is 3 is less than a number n plus 5. So let's see how we can convert this over here. 3, we can just write the number 3. Is less than is just translated as the less than symbol. A number n plus 5 is n, addition sign, and then 5. So our answer is 3 less than n plus 5. Now the last one that we have is 0 is greater than or equal to, which is translated over here, twice a number. Twice a number means 2 times the number x plus 1. So our inequality expression is 0 greater than or equal to 2x plus 1. Now we'll see how to solve these inequality expressions in the coming video. Now let's see how we can check the solution in a linear inequality. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. This means we can plug in more than one number into the inequality expression to see if it satisfies the condition. And this set of all solutions of an inequality is called the solution set. So we want to check this inequality expression with these three values, negative 6, negative 7, and negative 8. We want to check which one makes this inequality true. So how do you actually do that? Well, it's pretty simple. We just plug in this value of x into this expression. So the first one is negative 6. So we have x plus 5 is greater than or equal to negative 2. We plug negative 6 over here for x. Negative 6 plus 5 greater than or equal to negative 2. Negative 6 plus 5 is negative 1. Negative 1 greater than or equal to negative 2. Now we need to check whether this is true or false. Now negative 1 is greater than or equal to negative 2. This is a true statement. You can write here true. For this second value, we have negative 7. So we plug negative 7 over here. Negative 7 plus 5 greater than or equal to negative 2. So you can see that negative 7 plus 5 is negative 2. So negative 2 is greater than or equal to negative 2. This is also true. And the last one is negative 8. Negative 8 plus 5 greater than or equal to negative 2. So you can see that we are getting negative 8 plus 5 as negative 3. Negative 3 is greater than or equal to negative 2. This is a false statement. So you can see that multiple values can fit into the inequality expression and make the inequality true. But there are other values which can make the inequality false as well. Now let's try to solve this similar example over here. It says tell whether negative 4 is a solution of each inequality. We need to plug in negative 4 and see if it satisfies the inequality expression. Pretty simple. Let's try to solve this over here. So for the first one, we want to plug in negative 4. So negative 4 plus 8 less than negative 3. So negative 4 plus 8 is 4 less than negative 3. One of the strategies that we can often use to see whether the inequality is true or false is to use a number line. If we draw a number line, we can see that 4 is right here and negative 3 is right here. The numbers on the right are greater than the numbers on the left. So in this case, 4 is less than negative 3. This is a false statement. So this is not a solution over here. So this is a false statement. Now let's check the second one. We have negative 4.5 times negative 4 greater than negative 21. If we multiply, we are getting positive 18. 18 greater than negative 21. So negative 21 is somewhere here and 18 is all the way somewhere here. So the numbers on the right are greater than the numbers on the left. So this is a true statement. So in this case, negative 4 is a solution to this inequality, but not for this one. Awesome. Okay, here we'll graph each of these inequality. So the strategies are we mark the value on the number line and an open circle is used when a number is not a solution, and we draw a closed circle when a number is a solution, and then we draw an arrow to the left or right depending on the instruction. So the first problem, it says n greater than 3. So first thing is we circle these 3 on the number line. Here we have these 3 right here. Now since there is no equal sign underneath, we just keep the dot open. So an open circle is used when a number is not a solution. Here n greater than 3 means n equals 3 is not a solution. We don't have an equal sign underneath. So now greater than goes to the right side. So we just draw the arrow to the right. Pretty simple, pretty straightforward. Number 2, we have p less than or equal to negative 6. So mark this negative 6 right here. First draw the circle and then we close it because of the equal sign, and it's less than or equal to, so it goes to the left. Number 3, we have n less than or equal to 2. So mark this 2 right here and make it closed because of the equal sign. And then we go straight to the left because of this less than. Number 4, we have n less than negative 3. So we mark this negative 3 and we keep it open because we don't have an equal sign, and go to the left. Number 5, we have n greater than or equal to negative 6. So mark this negative 6, make it closed, and we go straight to the right because of this greater than sign. here n less than or equal to 1, we have this 1 right here, and we make it closed because of this equal sign, and you go straight to the left. Number 7, we have a greater than or equal to 6. We have this 6 right here, and we make it closed again, go to the right. And the last one, we have x less than -6. So we mark this -6 right here, make it open, and go to the left. Perfect. This is how you graph the inequality. I hope that makes sense. Practice this concept, and I'll see you in the next one. Awesome. We navigated through the exploration of writing inequalities and checking the solution. In our next video, we'll see how to solve inequalities and graph them. Now, let's get to study.